Hi everybody, it's Miss Austin. I'm going to go over some of the Unit 2 Lesson 22 practice problems that were assigned. So we're going to start with number 1B. So the strategy to solve a rational equation is to clear the denominator. So here we have two denominators. I'm going to multiply this side by x minus 1 and this side, which will then cancel those. And then I have this denominator, which I'm going to multiply x minus 2. And over here, the same thing, and that cancels. So I'm having x minus 1 times 1, which is 1x minus 1 equals 2 times x minus 2. I get 2x minus 4. Nice linear equation. I'm going to get my x's on one side. Get my numbers on the other side. Well, that was a plus 2. Oopsie daisy. So I'm actually going to subtract 4. I just noticed that was a plus 2. I had written that wrong. Sorry. So now x is negative 5. And then I just want to make sure that's not one of the undefined values. If I look at the denominator, x cannot be negative 2 or positive 1, which we're good. Okay. 1D, I've got x plus 8 and x plus 2. So I'm going to multiply by x plus 2 on both sides. I'm going to cancel. And then I'm going to multiply by x plus 8 on both sides. That's going to cancel. So on this side, I've got x plus 2 times x plus 2. You could make a box, or you could just use the acronym FOIL, first, outer, inner, last, equals, I'm going to do that multiplication in just a minute. Over here, I've just got the nice distributive property, 1x plus 8. So on the left-hand side, I get x squared plus 2x plus 2x plus 4 equals 1x plus 8. I'm going to combine my like terms, x squared plus 4x plus 4. Okay, it's a quadratic. I've got x squared and x to the first. So your strategy is to move everything to one side. So I'm going to minus this 1x and put it with the 4x over there. And then I'm going to move the 8. Okay, now once you've got everything on one side, the strategy to solve for x is one way, at least, is to factor. Okay, so I know x and x, and then these two numbers. Now this little shortcut works if this is just a 1. The two numbers that go in here are the two numbers that multiply to the last but add to the middle. What two numbers multiply to negative 4 but add to 3? Well, my choices are 4 and 1, 2 and 2. I'm ignoring the negative for now. So which one of those combos could make 3, 4, and 1? Drop those in. I need them to add up to a positive 3. So 4 is positive, 3 is negative. Okay, now that's just factored. Now I need to state the solutions. So what would make x plus 4 equal to 0? Negative 4. What would make x minus 1 equal to 0? Positive 1. And then just make sure that neither of those are an undefined value of x. Let's see. X cannot be negative 8 or negative 2. Neither of those showed up. Okay. Number 2. We're analyzing some student work here. It says Kieran is solving 2x minus 3 over x minus 1 equals 2 over x times x minus 1 and uses these steps. He checks his answer and finds that it isn't a solution to the original equation, so he writes no solutions. Unfortunately, he made a mistake. So first I'm just going to highlight this. So here's the original, and then I'm going to go see it's still here. So what did he do to both sides? Because whatever you do to one side, you do to the other. So it looks like he multiplied this side by x minus 1 and this side by x and x minus 1, which cleared the denominator, which is fine, except what's his mistake? Whatever you do to one side, you do to the other. You can't multiply this side by x and x minus 1 unless you do the same over here. Okay, so let's go fix that. So his mistake is he didn't multiply the left by x and x minus 1. He forgot that. So I'm going to cross this out and just keep going right here. So I'm going to add the x. Okay, so on this side, let's continue. We know this wipes all of that out. And we know the x minus 1's cancel, but you still have to multiply the x by these. Okay, so I'm going to show my work. I'm going to come down here. So I have 2x squared minus 3x equals, the only thing over here is a 2. It's a quadratic. How do you solve a quadratic? One strategy is to get everything to one side and factor. So I'm going to subtract my 2. No other constants over here, so I'm just going to put that at the end. Now, this one's not as easy to solve, or excuse me, to factor because it's got that 2 in front. So you can't do the little shortcut. So one way is to work backwards in the box. I do know, right? It's going to look like that. So I put the first term here. I put the last term here. What goes in these two boxes? Well, because this 2 comes into play, right? So what two numbers multiply to this diagonal, which is negative 4x squared, but add to the middle? Again, what are my choices? 4 and 1, 2 and 2. 4 and 1. That's the only one that can make a 3. 4x, 1x. This time I need it to make a negative 3. So the 4 is negative. Now I work backwards to see what was on the outside of this box, which will tell me what these two things are, my factors. So greatest common factor here is x. X times what makes this? 2x. X times what makes this? 1. 2x times what makes this? Negative 2. Then double check that the last square works. 1 times negative 2, yes. So there's one factor, 2x plus 1. Here's another factor, x minus 2. Okay, now that's not the solution, that's just the factored form. The solution is whatever makes that 0, which is negative 1/2, and whatever makes that 0, which is 2. All right. Moving on. Number 3, we've got a bunch of rational equations to solve. Again, what's the strategy? Clear the denominator. I'm going to multiply by x. That's going to cancel. X times x is x squared equals 25. Now, this is a quadratic, but it only has x squared in it. So you could bring the 25 over and factor it, but I would encourage to be more efficient since it's only got an x squared, while up here you had x squared and x, right? You couldn't isolate either of those. Here, your x squareds are isolated. So you can try to get x alone. You can take the square root, x equals plus or minus 5. All right, we make sure, is 5 okay? Yeah, the only undefined value here is 0. You cannot let x be 0 because that would make the denominator 0. All right, here we're going to clear the denominator. Multiply by x, multiply by x. Cancels. I'm going to put that in parentheses so I make sure I multiply both items by x. X squared plus 2x equals 6x minus 3. It's a quadratic that has x squareds and x's. Can't use this technique up here. I'm going to have to move everything over. I'm going to subtract 6x and then bring this 3. By the way, you can move both of those at the same time. I'm just moving one at a time for people to follow. Okay, now we're going to factor. Since there's nothing in front of this x squared, we can do the little shortcut. What two numbers multiply to 3 but add to negative 4? Well, the only numbers that multiply to 3 are 3 and 1. So that's easy. Now, what do the signs need to be to add up to negative 4? Negative, negative. And then negative times a negative makes a positive. So now the solutions are x equals 3 and x equals 1. Are those okay? Yes. Again, x was in the denominator, so the only thing that's going to make an x by itself turn into 0 is 0. We're good. All right, letter C. I've got two denominators, so I'm going to multiply both sides by x. That cancels, and both sides by x squared. That cancels. So we're not doing this one. I'm going to cross it out. So x times x is x squared equals 3 times x squared is 3x squared. I got to get all my x squareds on one side. So I get 0 equals 2x squared. Divide both sides by 2. 0 equals x squared. I mean, maybe you hopefully see it now. It's going to be right. The answer is 0. But then I look up here. There was an x in the denominator. X cannot be 0 because that would cause an undefined value. So this problem ends up having no solution. All right, I'm going to do one more so this video doesn't run too long. Number 5, it says, rewrite the rational function g of x equals x minus 9 over x in the form c plus r over x. So right now it's written over one denominator, but essentially both things are being divided by x. We want to break it apart so we can see the constant and then the rate or the part that's left being divided here. So we have x over x minus 9 over x. But then notice x over x, what does that cancel to? Something divided by itself is 1. So this is actually 1, minus 9 over x. And if you were to graph this would, or if you were asked, which you will be on your quiz, that's your horizontal asymptote. That constant, that number you get, is the horizontal asymptote that the graph is approaching. I hope this helped. And if you need help with 6, ask during class. Have a great day.